So today we're going to talk about cases where we're solving for triangles, and like they've been doing, they tell us 3 pieces of information and we need to find the other 3 out of the 3 sides and 3 angles. Those are the 6 pieces I'm talking about. The problem is the combination that they give us may not be enough to say for sure. With that law of sines only giving an acute possibility, we might also have an obtuse possibility. With the 3 things that they give us, there will be 2 sets of answers for the other 3 sides, and both would work with the 3 pieces of information that we're given. What we're going to be looking at will be when we have, and I've drawn a dotted line along the bottom because that's one of the sides that I'm not given, so I have no idea how long I should draw it. I know how long I need to draw both of the other sides actually, and I know this angle. So since I know how many degrees to make that, I know I've got to start here and go at that many degrees and measure it off for that long, and that's a fixed point. Over here, I know how long this side is, but I don't know the angle, so I don't really know which way to point. Even though I know it's got to be this long, I don't know whether I'm going to draw it going over to the right or going straight down or going over to the left or exactly where I'm going to draw it. So that's why I don't have this side drawn in just yet. There are going to be, book says 5 possible answers. I am going to say 4 possible answers because one of them is going to be the case where we have 2 sets of answers to this. The whole trick is going to be figuring out, or the first trick is going to be figuring out what is the height, because no matter what kind of angle I draw up there at the top for angle, I guess I should call it C as one of the angles I have defined. I don't know if I draw it out to the right, this would still be my height coming straight down. The shortest distance from that fixed point at C is going to be go straight down at 90 degrees. So if A and H are exactly the same, then I know that side's got to go exactly straight down, and I've got a right triangle. And that's one of my cases, and I've got the next slide that'll summarize all of these of what else going on. If, though, I figure out the shortest possible way to go with that, and if A happens to be, and this is going to be your favorite case, if this side that I'm told is shorter than H, it's too short to make it all the way down there. It can't possibly touch that bottom line. I'm going to have no triangle at all. Even if I draw A slanting in that way or out this way, if it's too short to make it down to that bottom dotted line at all, I can't get a triangle. Does that much make sense? So those are our first 2 possibilities here. So we figure out how tall H is, and they put 40 and 9 in there, but the same idea. So they've got these first 2 pictures here, like what I just drew. And that means if that side that I haven't drawn yet is exactly the same as the height, it's got to go straight down and make a right triangle. If it's not even long enough to be the height, it isn't really a triangle. I'm going to go back to that first slide, and I'm actually going to talk about what they call case 5 next, because to me, cases 3 and 4 are the ones that are going to have to go together and be done at the same time. And I'll explain what they're looking like. And again, I'll be back to this slide in a moment for you to finish copying this down if you haven't quite gotten this down. Let me go back to my slide on the first page here. Let me erase some of these things that I've scribbled in for those 2 cases that we just talked about. And again, I know exactly where point C has to be. I know how long little side A is. I know how long little a has to be. This time, I'm going to say A is bigger than the H because I've taken care of if it's equal or if it's less than. So everything else, A has to be longer than H. So if I were to draw it coming straight down, so I've got something kind of like this going on. If I drew it straight down, it would go too far. It would go past that line that I haven't known yet how long to draw it, because my side is longer than that distance straight down. However, for this case, I am going to say that this side that I have is also longer than the other side that I know. And I'm trying to figure out now, I know I can't make a right triangle. Do I send it this way or this way when I want to draw my triangle? For this case, if I try to swing it this way until it touches the line, the dotted line, I'd have to come way out here for it to be even with that dotted line. And then I've got a weird looking zigzag. That's not a triangle. So if my opposite side, little a, is longer than that first side, I can't swing it to the left and make a triangle. That means my only choice now is to swing this one around to the right. Let's see, I think it was about that long. So something like that. That is now my only choice of where to put this side. And that means in this case, this has to be an obtuse angle up there. And then I still need to find big B and little side C. So that's what we're going to copy down as case 5 in a moment when we go back to the next slide. Cases 3 and 4, where we have to draw it twice. We still have A's too long to go straight down and make a right triangle. But this time, instead of being bigger than that other side, it is smaller than the other side. In other words, on this one, let's see, A is less than B and bigger than H. So A is sandwiched in between sides B and H. That means I have enough room that I could take this purple line. I can't draw it straight down because it goes too far. I need it to exactly hit my dotted line. It could either swing this way or it could swing this way. Does that make sense? So that's when I have two possibilities. I'm going to have two possible sets of answers that I have to find. One, the way I've drawn it right now, this is acute. I don't know about the top one. I just have to go crunch through the numbers, whether it's acute or obtuse now. The other one would be where I swing it in like this, and then my angle is obtuse. And that is getting big B because it's across from this side. Is acute is one set, or obtuse for the other set of answers. So from the picture, do you kind of get the idea of the possibilities of what's going on? So to finish writing down the rules of how you're going to be checking those, cases 3 and 4, that's where the side you know is sandwiched between the height and the other side you know. You have to solve it. If B is acute, here are the possibilities. If B is obtuse, here are the possibilities. However, if A is bigger than H, but also bigger than the other side, then there is just one triangle, and that one has that angle up at the top, being obtuse. And technically, you don't have to always draw these the way that I did. That's what I'm going to do. It always helps me if my unknown one, the one I did as a dotted line, is the one that goes straight across along the bottom. And then the angle that I know, I always draw on the left. And then I can put the two sides that I know where they're in the right place, which one's across from the angle that I know it's degrees, and which one is the other one in them. All right, so here's our first one. And so we start off by drawing a sketch on this What do we know? So as I said, I always like to have the side I don't know down here. And then this needs to look kind of sort of like 40 degrees and however long I feel like drawing it. And that's, I'm going to call that A. The side opposite that angle that I know needs to be 4. And the side adjacent to it that I know needs to be 9. So I start off with my picture. Do you remember what we said was the first thing that we have to figure out, the first key piece of information we need? The height. So first we're going to find the height. And to do that, it would go right here. And if that's a right triangle, which trig ratio would involve the h and the 9 and the 40 degrees? Dylan? So we could write down sine of 40 degrees is h over 9. So h is 9 sine 40 degrees, and I need you to punch that in on your calculators for me. And that's always going to be the pattern. If you want, you can always set up the triangle and write down that the sine is h over and then solve that for h. Or you can just memorize that the height is always going to be this adjacent side times the sine of the angle that you know. And just waiting for everybody to finish getting this punched in on your calculators. Everybody's going to want to be practicing going through these steps. So everybody have your calculator out and type these in as we go through them. Gavin, what did you get for the height on this? 5 point what? 785. Others getting that also? Okay, then the next thing we needed to do was to compare that height to that opposite side that we know, so h and a. So we know that we have 4. That is shorter than the height. So we need to think about what that means. That means when we try to draw in this side, it's shorter than the height. No matter which way we angle it, if it's shorter than the height, can we get a triangle? So no triangle exists. And those are probably going to be your favorite because they're so fast. Yes. You don't have to memorize case number. It was case 2, but you do not have to memorize it. You do have to know, but you do have to write in the answer, no triangle exists. And we always draw a picture, and this one said draw a picture. Well, it's going to be an incomplete triangle like that. You're going to have wherever you want to put what I drew in blue, you've got that gap. It doesn't make it all the way down to the bottom line. All right, I bet you guys can guess. If I'm only doing one more example, I bet you can guess what's going to happen with this other example. Maddie, what's your guess? Yes, and more specifically, it's going to be that hard kind. We're going to have 2 sets of answers. But I'm also going to show you some calculator tricks to save some time, especially on a test when time makes such a difference. So we're going to start off with our sketch. We have a side down here along the bottom. We don't know how long to draw it. We know that we have this angle that we're going to make look kind of sort of like 32 degrees. That's big A. Across from big A would be little a, which is 6, and I don't know which way to tilt it yet, because I don't know how big that angle up at the top is going to be. I know this side is going to be 8, which means B is going to be my angle down here somewhere, C is going to be my angle up there somewhere, and little c is going to be how long I end up drawing that dotted line. So what's our first thing that we have to find? The height. And I said we can memorize that it's always this adjacent side times the sine of that angle that we're given. Or you can draw the HN and write down sine of 32 equals h over 8, solve for h equals 8 sine 32. And maybe I've talked long enough that you've now typed that in on your calculators. and have some answers for me. Kate, do you have H for me? So H is 4.239. So straight down would be 4.239. I have a side that's 6. Is that long enough to make a triangle? So I've got 1 or 2 triangles. That's what I know so far. Okay, so let me get rid of those dotted lines. Then I also need to compare the 6 to the 8. So I can also say that the 6 is bigger than that H. And how does the 6 compare to this other side that I know? It's less than. So I've got enough space. I can either swing it this way or this way. I don't have to come all the way out to the left of that line where B is 8. Since the 6 is sandwiched in between the height and the other side that I know, there are 2 triangles. So I have to solve case 1 and case 2. So let's start off for case 1. And let's see, maybe I'll do that up here. So for case 1, I am going to look at what I know and think about, okay, all of my tools, Pythagorean theorem, triangle sum, law of sines, law of cosines. I have little a and big A across from each other. So which one of those tools does that mean I need to use? Law of sines. So I'm going to set up 6 over the sine of 32 needs to be 8 over the sine of B. Need to solve that for B, so let's see, 8 sine 32 degrees equals 6 times the sine of B, so sine of B is that divided by 6. So B is the inverse sine of 8 sine 32 over 6. Paul, you have our first possible B. So our first possible B is 44.956 degrees, and you need to store that. So B is my angle down here on the bottom. This is the one where I get something acute. So that means I have tilted it out this way. So I'm looking at a triangle kind of like that. Because now I've drawn it so that this B is acute, my first possibility. Now I know 32 and I know angle B, and I've stored angle B. How do I get angle C? Dylan? So I'm going to use triangle sum, 180 minus the 32 minus that stored B. So my first possibility for angle C. Macy, you have our first possible C? 103.044. So when I swing it out this way, that angle up at the top ended up being something that was obtuse. And now I need you to store that. I need to be sure I label it with a degree sign. Store that as C. Now we're just left with little side C. So for that, we can go back to our law of sines, and we can say 6 over the sine of 32 degrees is little c over the sine of the C that we've just stored. And that means 6 times the sine of the stored C is sine of 32 times little c, so divide by sine of 32 degrees. And that will be our first possibility for little side C. Lily, have you had a chance to type that in? Not yet. Alex, how about you? Anybody who hasn't answered yet, who has that typed in? Maddie, you have it? That's what I got. So little c1 is 11.030. These all go together. That's why I put the subscript on them and I've circled them. That's one set of my solutions. Now, when you're doing these, plan your work. You should have some corner, maybe about a third of your problem set box left to do case 2. So what I would like you to do is to draw some kind of a box wherever your space is that's still left to work on in your problem set box. A little bit different on this one since it's just taking notes, but so that it's easy to tell these are the ones that go together and these are the other case. This one's going to be a heck of a lot less writing. Now we want to get our other possibility for our angle down there at the bottom. This is going to be the one where we still have like this, but we're going to swing it in like this time. So this is the one where B is now going to be obtuse. And this was A, and this was C, and this was 8, and 32, and 6, I think it was. So to get our second B, all we have to do is take 180 minus that B that we stored. And tell me what you got. You don't get to answer everything. I have to do some of the work today. Nope, minus our stored B. Before we did 180 minus, before we had to find it with the inverse sign. We don't have to do all of this again. All we have to, because that would still give us the acute one. And if we'd gotten this acute answer right here, we'd subtract it from 180 to change it to the obtuse one. Faith, what do you have? 135.044. Store this now as B. It will erase your first B and change it to this. Now, to get your second angle C, wait before you type it in. We still need to do 180 minus 32 minus the stored B. So I want you to think which is faster for you, depending on where it is in your work. You could scroll up to the line where you typed 180 minus 32 minus B, so that that's highlighted, and hit enter to recopy it and hit enter again. Or if you think you could type faster, since this is short, 180 minus 32 minus B. But that's why it's important that you change the B by restoring it. But does that make sense? Either scroll up and copy, or since that one's short, retype it again. Bren? You scroll up to it so that it's highlighted. You use your up arrow, and once it's highlighted, you hit enter, and it'll recopy it down at the bottom as the next thing you're trying to evaluate. You can also then backspace to change something in it if you simply made a mistake, or if the problem's not very much different, and that saves some time in there. Rhea, do you have our new B? I mean, our new C. We've already got our new B. That's what I got. Anybody else getting 12.956? And that one is also degrees. Store it, because we want to get rid of the old C, and we want this to now be the C that the calculator remembers. Now we need to do exactly this calculation again. 6 sine of the stored C over sine 32. I can scroll up and find that and highlight it much faster than I can retype all of that. Control divided by 6 trig, select the sign, type C, go down to the denominator and all of that. Scroll up so this is highlighted. hit enter to copy it, and then just hit enter again. And that's all that you've got to do for this one to get little c2. Is that working for everybody to copy it? Jack, what do you have? 2.538. Does everybody understand what we did there? I always do the one where I swing it out here to the right first, because that gives me the acute B, because that's what's already on my calculator. And it's less going back and forth and converting things that I've already converted once to be able to finish it up that way. And then I've got my two sets, I've got my two pictures, I've separated which numbers go together as one group so I can comprehend the answers in there. Anybody with a question?